Hi, this is Sami. We're going to be doing algebra, but what I'm going to show you in this video, though, how to evolve from caveman to modern man of doing algebra. So watch and see. Okay. So here's the caveman of doing algebra. So here we go. Minus a 6 from both sides. That's what we learned from before. And that 6 will cancel that 6, and therefore x would equal 11 minus 6, which is 5. Now here, it's even more complicated when you're doing caveman algebra. So you minus 3 from both sides. And what a lot of students, when they do that, they write x equals 6, forgetting that negative here belongs to the 6. So don't forget that negative, my friend. And now this is the same as having -1 in front of the x. So you divide both sides by -1, and you get x equals -6. Now let's go back and check both of these answers to make sure we got them correct. Okay, so that's what you could do to check your answers. So now we got x equals 5 here, even though it's very easy to see with that one. So if you go sub in 5 for the x, you go 5 plus 6, and 5 plus 6 gives you 11, which is the same as the answer right here. So that's 11 equals 11, so that's good. How about here, if we sub in the -6 for x, so that becomes 3 minus -6. Does that equal 9? We'll find out. So 3 minus -6 just becomes 3 plus 6, because negative and negative makes it plus 9. So 9 equals 9. So that's also checked. So that one works correctly. Okay. Unfortunately, in a lot of schools, we still teach that, and we are not evolving to make things a bit easier. And if we have the whole year with a student, I think we might show them an easier way of doing this and make their life a lot easier. So that's what I'm going to do on the next slide. I'm going to erase all of this. So now it's modern man of doing algebra. So you see here, this is x plus 6. So we write x equals 11, and we move the 6 to the other side. And when the 6 moves to the other side, changes the sign. So it becomes -6. So therefore, x equals 5. Now you might argue, you know, we could do it that way or this way. How is that modern? Okay, so maybe you could argue with me and say that here, but how about here? Let me show you a way of making this so much easier than how we did it in the previous caveman algebra. So here, what I want to do, I want to isolate the x. Always remember, when you're doing algebra, you're trying to isolate the variable. So what I'm going to do, I'm going to move this x this way. And the reason I want to move it this way to the other side of the equal sign, because it has a negative sign. And I know when I move things to the other side of the equal sign, the sign changes to positive. And simultaneously, I'll move the 9 this way to the left side of the equal sign. So what happens? This becomes 3. The 9 moves to the other side of the equal sign. It has a positive that we don't write in front of it. So that changes to minus. And the negative x, when it moves to the right side of the equal sign, it becomes positive. And 3 minus 9 is -6 equals x. Now you tell me, is this faster or the caveman way of doing algebra? So that's why I'm showing you this. It's a lot faster. So again, let me go over this again. In this kind of situation, just know anything could move to the other side of the equal sign. But if it does move, you have to change the sign. So here, I want, because the x has a negative in front of it, I don't like that negative sign in front of the x. So I decided to move the negative x to this side and the 9 to the other side. So the negative x, when it moved to the other side of the equal sign, became positive x. And simultaneously, the 9, when it moved to this side of the equal sign, it became -9. So remember, all of this moved to the other side, you know, and that's how it became positive. The negative became positive, and the 9 has a positive in front of it. So when it moved to this side, it became -9, and the 3 stayed where it is. So nothing changes with the 3. So it just stays as +3, and then -9 equals, and x equals -6. Okay. Now let's go to the next slide. So this is a caveman algebra. So if you want to stay this way, or you want to change to the modern man. So there you go, the caveman, or what you've been taught in school. It's, okay, we add a 2 this way, and we add a 2 this way. So now we have 3x and this 2 is canceled, equals x plus 10. Now what we want to do, we minus x from both sides to get x's to the same side. So and minus x from here. So that becomes 2x equals 10. Now we divide both sides by 2 by 2. Therefore, x equals 5. Okay, so that's again, remember this is caveman. Okay, now how about this one? It gets even more complicated. So let's minus a 7 from this side, minus a 7 from this side. So don't forget when that goes, that negative belongs to the 2x. So don't forget to write that negative 2x there equals 3x minus 20, because negative 13 minus 7 is negative 20. Now we got to take away 3x from this side because we want to bring the x's to one side and do the same thing here. And that will cancel. And this will give me negative 5x equals negative 20. And therefore, x would equal, you divide both sides by negative 5 by negative 5. X equals 4. Okay. Now, let's just go back and test our answers to make sure they're correct. And when we're testing if they're correct, all we need to do is just sub in the 5 for the x here and the x here, and then make sure the left side equals the right side. So 3 times 5 minus 2, and the other side is sub in 5 for the x plus 2. Sorry, plus 8, sorry. So you're subbing it into the original equation here. So that's, so 3 times 5 is 15. 15 minus 2 is 13. And 5 plus 8 is 13. So this one checks. Now let's go to this one. So we want to test, make sure that it works. And if we sub in 4 for the x equals, and we sub in 4 for the x here, minus 13. This becomes 7 minus 8 equals, and that's 12 minus 13. So that gives me negative 1 equals negative 1. So we know that's checks as well. So the answer is correct. And that's caveman. Now let's go to modern man and see how we could do this a bit faster. Okay. And you know what? A lot of students are resistant to doing this. It's almost like they don't trust this works. They don't trust this works all the time. Not this, but what I'm going to show you after. Trust me, it works all the time. In these kind of situations, you could make your life so much easier. So let's go to the next slide. So again, let's get rid of that caveman algebra, and let's do modern man algebra. So simultaneously, listen to this. Simultaneously, I'm going to move the x's to one side. I want the x's to be on one side, and I want the numbers that don't have any x's to be on the other side. So basically, I'm going to move the x from the x plus 8 to the left, and I'm going to move the negative 2 with the 3x to the right. And you remember I said, if you do that, you have to change the sign. So the 3x stays exactly what it is. This x is moving to the left side. It becomes minus x because it's positive here. Equals this 8 stays on the right side, but this negative 2 wants to move to the right side. So it changes the sign to become plus 2. Now 3x minus x is 2x equals 10. Divide both sides by 2 by 2. X equals 5. Okay. Now how about here? Here, two things you could do. You want the x's to come to one side. Let's say I don't want to have an x with a negative number. I know if I move the 3x to this side, it's going to be minus 3x, and it's going to give me negative 5x, but I don't want to deal with negative numbers. Let's say if you want to do that. And negative numbers are fine, you know. So you could also move the numbers without the x's to the left side. So basically you're moving the negative 13 to that side, which makes this 7. The 7 is going to stay there. Plus 13, because if you move the negative 13 to the other side of the equal sign or to the left side of the equal sign, it becomes positive. And we still have the 3x on the right-hand side of the equal sign, and I'm moving the negative 2x to the right side. So what I'm doing, basically, I'm moving this to the left side, and I'm moving this to the right side. So when I move this to the right side, of course, it's going to change the sign. It's going to become plus 2x. Now we have 20 equals 5x. and then I divide both sides by 5, and therefore x equals 4. All right, so that is much faster and easier, and the chance of making a mistake here is a lot less. The thing is, trust it, like it works all the time. In these kind of situations, it works all the time. Like don't have any doubts on your mind. This works all the time. Trust me, learn how to do it this way. You'll become so much faster moving things around in algebra. Okay, so let's go to the next one. What we learned in school is cross multiplying. And we always taught cross multiplying that you have to cross the 9 here and the 3 there. So let's say we do that. All right. So we're going to do it the caveman way. So 3 goes there, the 9 goes there. So that gives me 3 times 2x is 6x, and 9 times 8 is 72. So that's what we get. And then we divide both sides by 6, and we get x equals 12. Yeah. Now we're going to do this the modern man, and you might want to argue about this one, but I'll let you make that decision. Yeah. So modern man tells me, let's rewind. So what I tell you to, and some mathematicians, they arrive to this on their own, like they just see it works. Now the way I do it in one shot. I go then so I do it in one shot. I go the 9 goes there, and the 2 goes there. So cross multiplying. Let's go back to that. Cross multiplying means if you cross the equal sign, if you're on the bottom, you go to the top. And if you're on the top and you cross the equal sign, you go to the bottom. So the number on top, when it crosses the equal sign, it goes to the bottom. That's in cross multiplying. So that's different from what we did in the earlier slides. So this here means the 2, it's on top, it's going to go to the bottom. And the 9 is on the bottom, is going to go to the top. And you're left with the x. So that's how the x now stays by itself. It's only the 2 that crosses, because you're interested in getting the x on its own, isolating the x. So therefore, the 9 goes to the top. So it becomes 9 times 8 over, and the 2 goes in the bottom. So it becomes 3 times 2, because the 2 went down there. Now, for me, I like to reduce right here. The 3 goes into itself once, it goes into 9 3 times. 2 goes into itself once, it goes into 8 4 times. Now 3 times 4 is 12, and you have 1 on the bottom. You don't have to write that 1 on the bottom. So that is the way I would do it, and it's a lot faster. It's one step, you get everything isolated, you get the x isolated. So in one step, you isolate the x. Okay, so now let's go to another question, and we'll do it the caveman, or what I think it's a caveman way of doing it. So here's caveman, or what we learn in school. So what we learn in school is that you cross this way, and you cross the 2 that way. So now you have 30 equals 5x. Then you divide both sides by 5. That cancels, x equals 6. So let's just rewind. We're evolving now. So look at this. As I said earlier, if you cross the multiplication, if you cross the equal sign, when you cross the equal sign, so you're going to the other side of the equal sign. In this situation, if the thing is on the bottom, it goes to the top. If the thing is on top, it goes on the bottom. Remember, I said thing, so I didn't say number. Anything, anything that's on the bottom, when it crosses the equal sign, goes to the top. And if it's on top, when it crosses the equal sign, it goes to the bottom. Now I want to isolate the x again. Okay. But the x here is on the bottom. And if I want to isolate x, definitely I want it to be on top. So what's going to happen? These guys, both of them going to cross, and this is going to cross there. So the 5 will go to where the x is, the x goes where the 5 is, and then the 2 goes to where the 15 is. So you have 15 times 2, the 5 crosses the equal sign, it goes to the bottom, and the x simultaneously crosses, and it goes to where the 5 is. Remember, 5 is on top. So the x went to the top there, the 2 cross, so you don't have anything under the x anymore. And now just reduce the 5 in itself once, and then it into 15 3 times. So x equals 6. One more question. So let's do this one with the caveman method of doing things. So cross multiplying, this crosses this way and this crosses this way. Remember, 5 times 12 is going to be 60. And when the x plus 1 crosses, you're going to have 6. And then you're going to have the x plus 1 inside the bracket like this. And now you go 60 equals 6x plus 6, because you distribute the 6 in both here and there. Now we minus 60 from both sides, minus 6, sorry, from both sides. And that gives you 54 equals 6x. And then divide both sides by 6. And x would give you 9. So we're going through evolution, and now let's just go right there, or maybe even here. So now let's rewind and go back. As we evolve algebraically, that's what we should be doing. Yeah. Cross multiplying. Again, if you cross, as I said earlier, from the bottom, you go to the top. If you're on the top, go to the bottom. So this x plus 1 is on the bottom, and I don't like that at all. So I'm going to get the 5 to go there. And the 6 and the x plus 1 will exchange places, because 6 is crossing is going to the bottom right there, and x plus 1 is crossing is going to go to the top right there. So what are we going to have? We're going to have 12 times 5 over 6, and the x plus 1 goes to where the 6 is. Now, reduce, that gives you 1. That gives you 2. Now, 2 times 5 is 10, and you have 1 on the bottom. You don't even have to write that. Equals x plus 1. And when you move the 1 to the other side, it becomes minus 1. You remember, I don't do the caveman minus 1 from both sides. You just move this plus 1 to the other side. And when I move it, I know it changes the sign. So that's modern man x. And therefore, x equals 9. Now you decide if you want to stay with the caveman or you want to go to the modern man. It's up to you. I'm just showing you how you could evolve mathematically and algebraically. Okay, as always, thanks for watching. Till next time, bye-bye. But don't forget to hit that like button, share with family and friends, subscribe to my channel, keep supporting. Thank you.